Chair Bear Digital Learning. Software Development Essentials. Handbook for Software Development Apprentices. The Software Development Lifecycle. The Software Development Lifecycle, SDLC, is a framework describing a process for planning, building, testing, and deploying a system. The process can apply to both hardware and software systems. It consists of the following stages: feasibility, requirements, design, develop, test, implement, and maintain. Feasibility study involves investigation and research in order to evaluate the project's potential for success to support decision-making and secure funding. It weighs the resources and costs involved against the project's value. This returns the return on investment, ROI. ROI formula. ROI equals net profit/cost of investment, x 100. Only projects with a reasonable ROI will be supported. There are different types of feasibility, explored further below. Technical feasibility. Will the proposed system perform to the required specification? Outline technical systems options proposed to use. Social feasibility. Consideration of whether the proposed system would prove acceptable to the people who would be affected by its introduction. Describe the effect on users from the introduction of the new system. Will there be a need for retraining the workforce? Will there be a need for relocation of some of the workforce? Will some jobs become desk-idled? Describe how you propose to ensure user cooperation before changes are introduced. Economic feasibility. Consider the costs/benefits of the proposed system. Detail the costs that will be incurred by the organization adopting the new system, consider development costs and running costs. Requirements engineering. Aims to secure understanding in what the business needs the software to do. Requirements must be elicited, analyzed, documented, and validated by the business analyst. The requirements are developed through 4 stages. 1. Elicitation. Elicitation practices typically include JAD, joint application development, techniques such as interviews, questionnaires, user observation, use cases, role-playing, and prototyping. This is likely to involve many different participants. Interviews. Strengths. Allows analysts to probe into greater depth. Analyst can respond in real time to interviewee to ensure clarity of understanding. Weaknesses. Time-consuming and costly. Subject to bias, and interviews may produce conflicting results. Questionnaires. Strengths. Allows collection of quantitative data. Faster method of gathering from large sample size. Weaknesses. Difficult to create well-balanced questionnaire. Difficult to receive good response rates. Observation. Strengths. Identify peak and quit periods. Check validity of information gathered in other methods. Weaknesses. Participants often don't accurately recall everything they do. People's behavior changes when they are watched. 2. Elaboration. This stage provides greater depth to the reasoning of each requirement or user commentary, and breaks down each requirement or commentary into technical details. Methods used by the business analyst in this stage will include developing use cases, creating flow diagrams, class models, GUI mock UPS, and assigning business rules. This phase also assists with addressing known risk factors and establishes or validates the system architecture. 3. Validation. This stage verifies that requirements are complete and testable. The requirements document should be checked for ambiguities, conflicts, and errors, while developers and testers should check the user commentary to ensure it matches up with criteria. Techniques used at this stage will include discussions, simulations, and face-to-face meetings. 4. Acceptance. This is the final stage in requirements definition. It only happens when the requirements have been verified and agreed by all the stakeholders. It is during this stage that the business analysts create a baseline of the requirements so that technical development can start and test planning can commence. This is done through an SRS, System/software requirement specification, document which consists of all the product requirements to be designed and developed during the project life cycle. The functional and non-functional requirements will also be clearly specified here. Functional requirements. In software development, a functional requirement defines a function of a system or its component. A function is described as a set of inputs, the behavior, and outputs. An example of a functional requirement would be a system that needs to be able to store usernames in a database. Non-functional requirements. A non-functional requirement, sometimes referred to as NFR, is a requirement that specifies criteria that can be used to judge the operation of a system, rather than specific behaviors, such as speed or scalability. Non-functional requirements are not any less important than functional. An example of a non-functional requirement would be a system that should be able to carry out 1,000 transactions per second. A non-functional requirement is almost like a smart objective. It is measurable. Further example. A page has a video on it. There should be a facility for the user to change the video-audio volume. The audio should be controlled by a slider. The functional requirement will be the ability to change the audio. The non-functional requirement will be the slider. This is to do with the GUI. It is a matter of choice. There are multiple options available to change the volume. You could have just as easily chosen a knob. If a system calls a function to make something happen, that is a functional requirement. How you make the function happen is not functional, as it is a matter of choice. The slider being moved to increase the audio is non-functional. It could have just as easily been a knob turned up. However, the audio increasing as a result is functional. Design. The SRS from the requirements stage is the reference for product architects to decide the best architecture for the product to be developed. Based on the requirements specified in the SRS, usually more than one design approach is proposed and documented in a design document specification, DDS. This DDS is reviewed by stakeholders and an approach is selected based on variables such as risk assessment, product robustness, design modularity, budget and time constraints. The chosen design is elaborated upon. System architecture. In software development, architecture is a description or model of a system that includes all details of the system such as the structure, components, behavior, and attributes. It is not just a design and not just about the structure of a system. It encompasses all aspects of a system, including internal and external interactions. There are many types of architecture, however the main ones covered here are enterprise, business, solution, and infrastructure architecture. Enterprise architecture. This is the highest level architecture, and it is all about the organization as a whole involving planning and managing the structure and strategy of the organization in all respects, bringing both the business and the IT aspects together. It is primarily concerned with the highest level, long-term, strategic issues, and it is comprised of human, political, social, software and hardware components. Inputs to EA. As the scope of EA covers the whole organization, inputs to this architecture are varied and from all aspects of the business including those from all other architectures, although at this level they are not as specific. Market and competitor analysis. Financial data. Employee data. Future projections. Its system usage and performance data. Materials and resource levels/costs. Legal and governance. Strategic vision. Business architecture. A subset of EA, business architecture is all about aligning business requirements and operations with the strategic objectives that EA is concerned with, how the organization's strategic objectives are going to be executed. Inputs to business architecture. As the business architecture is focused on the business objectives of the organization, this type of architecture has a narrower set of inputs than EA. Business drivers. Organizational/structure model. Financial models. Market/competitor analysis. Solution architecture. A level down from business architecture, Solution architecture is concerned with the structure and behavior of solutions, solutions typically being systems like software applications and their accompanying processes. These solutions implement the operational business objectives. Solution architecture therefore is a description of the software, hardware, networks, data, processes and procedures that make up a solution to a business need. And this level can be considered to contain software, data, and infrastructure as subsets. Software architecture. Software itself has many different architectures and designs, with modern software developments using a multi-tiered approach where the software code itself is split into different components each with its own purpose and functionality. Benefits of tiered software architecture are increased maintainability and supportability, faster code development and modular, reusable code. The three-tier architecture layers are user interface. This layer is the code for the interface/GUI. Business logic. This layer is where the processing of UI actions and data is performed according to the business rules. Data. This layer is where the data is stored, e.g. in a database, and code interacts with the stored data. Inputs to solution architecture. As solution architecture is focused on the implementation of business objectives, inputs at this level are related to the needs of the business and its stakeholders. Business drivers and need. User requirements. Budget and resources. Infrastructure architecture. Also known as technology infrastructure, this architecture is concerned with modeling the hardware elements within an organization, and the interaction and relationships between them. This includes client devices, servers, all networking and communications equipment, and the location of databases. Without infrastructure architecture, the other higher-level architectures would not be possible, as it is the basis for organization and system communications, the hosting point for applications, and the connection to external stakeholders and systems. Inputs to infrastructure architecture. These include solution/software capacity and performance requirements, user needs, budgets and resources, technologies available, data modeling. Data modeling is the exploration of data-oriented structures, and like other modeling techniques explored further in deliverables, data models can be used for purposes from high-level conceptualization to physical data models. Physical data modeling is conceptually like class modeling, with the goal being to design databases, depicting the tables, the data column in those tables, and the relationship between said tables. There are three types of data models. Conceptual. This model defines what the system contains, its purpose is to organize, scope and define business concepts and rules. It is typically created by the business stakeholders and architects. Logical. This model defines how the system should be implemented regardless of the database management system, DBMS. Its purpose is to develop a technical map of rules and data structures. It is usually created by the architects and business analysts. Physical. This model describes how the system will be implemented using a specific DBMS system, the purpose being the actual implementation of the database. This is created by developers and the database administrators. Interface design. When designing the software, there are two main ways to model the interface design. These are wireframing and prototyping. A wireframe is a visual layout of how a user interface, UI, should look. They include basic information such as the position of elements like images or forms, and can be anything from a rough sketch to a detailed plan. Design principles. Good design should follow these principles. No wasted space, but no cluttering either. Don't give an unnecessarily large number of options, Hick's law. Use of appropriate colors, psychology of colors. Make controls large, and easy to reach, Fitts law. Design constraints. There are obvious constraints such as performance capabilities of the hardware, time constraints, and staffing limitations. However, there are three main restrictions that mold a system design. These are legal. These are constraints on development enforced by law. One example would be 2018's Data Protection Act, GDPR. Ethical. Ethical refers to moral values and considering what is generally thought to be good practice. One such good practice is developing with the public interest in mind. Financial. This means there will be a budget to stick to. Things that fall under finances include staff and resource cost. Often cost/benefit analysis is performed, and expenditure monitored at particular development phases, depending on methodology used. An example of constraints in practice. A business is developing some email marketing software that allows users to make a marketing email using a template and send it to their emailing list. Funds are running a little low, and so the product is packaged and sold without fully being complete. An email unsubscribe button is left missing out of the templates. The ethical issue here is that the company knowingly is selling an uncompleted product but still selling it as having all the bells and whistles. The legal issue is that email recipients have no way of unsubscribing from the emails. Building in security. Design also incorporates consideration of quality, security, and constraints. Often referred to as building security in. This consideration leads to secure development, which is a practice to ensure that the code and processes that go into developing applications are as secure as possible. It includes threat modeling. This asks what parts of the software are easily compromised, and what is the impact. Threats will be prioritized, and if a threat cannot be mitigated with security control, the design is changed or the risk is assumed. Testing. This can be static code analysis in which code is analyzed without running, or testing the software against a modeled threat. Security vs. resilience. Security is the proactive protection against threats, for example firewalls and antivirus software, whilst resilience, also known as threat mitigation, is the reactive countermeasures that limit the damage an attack has on a system and infrastructure, for example system backups. Common security attacks. Cross-site scripting, XSS. Typically found in web applications, XSS enables attackers to inject malicious client-side scripts into web pages viewed by other users. A XSS vulnerability may be used by attackers to bypass access controls such as the same origin policy. Example. An attacker discovers a XSS vulnerability on a website. This is usually a user input field that has not been properly configured and restricted, which enables attackers to place scripting markup within the input area and run it. Preventing this is dependent on the language behind the website. For example, with PHP you can use PHP's HTML specialcars function to prevent this. Whilst using HTML specialcars, if a user tried to submit the following in a text field, something, it would not be executed as it would be saved in HTML escaped code like this. Script something/script. The attacker then injects a malicious script that steals each visitor's session cookies, which will say something to the computer akin to "this is a valid user." The attacker can then use these cookies to gain access to whatever privileges the original user has. If they were admin, for example, the attacker would then have access to any important or sensitive information the administrator had access to. Cross-site request forgery. Unlike XSS, which exploits the trust a user has for a site, CSRF exploits the trust a site has in a user's browser. CSRF is a type of malicious exploitation of a site where unauthorized commands are transmitted from a user that the application trusts, without the user's interaction or knowledge. Example. Jem receives an email from a stranger that asks if they have seen the most recent news about a breaking news robbery in their country. The email contains a link that appears to go to a news site. Jem clicks the link. The link itself now attempts to access funds in Jem's bank account, and since the request comes from Jem's computer and it has cookies authenticating them, the link has access and successfully transfers funds to another bank account. SQL injection. An infamous type of attack, SQL injection is a code injection technique similar to cross-site scripting in which nefarious SQL statements are inserted into entry fields to attack data-driven applications. For example, to send all the database contents to the attacker. Example: a basic login box, username, password, the SQL injection, username, or 1 = 1 ***, password, */*. What this means to the database. Select * from users where username equals or 1 = 1 ** and password equals */*. Translation: select all from the users table where username is equal to nothing or equal to true, to the database. If a true value is passed, it means a value was found, and password is cancelled out as the */* turns the rest of the statement into a comment. An easy fix is to prevent the input boxes from accepting special characters. Denial of service attack, DOS. In a DOS attack, the attacker aims to make a machine or network resource unavailable to its intended users by either temporarily or permanently disrupting the services of a host. It is typically accomplished by flooding the targeted machine or source with a staggering amount of requests in an attempt to overload the system, which will prevent legitimate requests from being fulfilled. There are also attacks that focus on manipulating a person into divulging information or access to a computer system. This is social engineering. Below are a few examples of this. Phishing emails. This involves getting users to divulge information by tricking them with fictitious emails. Whale phishing includes targeting a more profitable user, someone who is important or wealthier than a standard target. A juicer target, if you will. For example, a CEO of a company instead of a receptionist. Spear phishing includes using user-specific emails, to make users feel it is more reliable. Such as using your name. Pretexting. This includes using a plausible scenario to gain people's trust. Waterhole attack. This includes targeting social websites or online gathering places for a particular sort of person. As the attacker knows the general subject or topic being discussed here, they can find it easier to coin their attacks by playing to the user's weaknesses. For example, a football fan forum, and the attacker posting a message saying they need money to support their son's football team. They could follow the message up with a plea for other football fans to send money to support the non-existing team. Development is the phase where technical components are created, procured, or configured. To build in security, developers must work with testers and security experts to better understand their code from an attacker's point of view. They should also train in secure coding practices and keep up to date with the latest cyber attacks and vulnerabilities. Any software that requires user input should also be validated. Proactive security approaches. 3 examples of proactive approaches are: defensive programming. Programming that incorporates exception handling, validation and other security features. The worst-case scenario is imagined, and then coding measures put in place to try to prevent it. Permission settings. This incorporates creating permissions for access to files and data, and setting different user access levels. Physical infrastructure. This includes utilizing physical measures of protection such as biometrics, CCTV, and locks. Prototyping is the activity of creating early sample versions of software, typically simulating only a few aspects of the final product. There are 2 models for prototyping: throwaway model and evolutionary model. Strengths: confusing, missing or difficult functions can be identified. Errors can be detected early. Weaknesses: leads to implement and then repair way of working. May increase complexity of the system as scope may expand beyond original. Throwaway model. This prototype is thrown away once it has been reviewed. They are quick to produce, and often visually resemble the final product but have no to little functionality. Evolutionary model. This prototype evolves into the final product. The main goal is to build a very robust prototype in a structured manner and then refine it. The prototype forms the heart of the new system and the improvements and further requirements will then be built.